Hello, Mrs. H here. Osmosis exam questions can be quite tricky, so I thought we would walk through some together. Question 1. The diagram shows the plant cell after 1 hour in distilled water, after 1 hour in strong sugar solution. Describe 2 ways in which the cell in the strong sugar solution is different from the cell in distilled water. The one in strong sugar solution has a smaller vacuole and it also has less cytoplasm. They have only asked for 2, so we're only going to put 2, but other possible answers could be the cell membrane has pulled away from the cell wall, or the sugar solution is between the cell membrane and the cell wall. Explain how the differences between the cell in the strong sugar solution and the cell in distilled water were caused. Then look at the cells. This cell is placed in distilled water, so there is a high water concentration outside of the cell. And this cell is in a strong sugar solution, and this means there is a lower water concentration outside of the cell. So remember your osmosis definition and then apply it to this question and make it clear which cell you are referring to. Water molecules will move from a higher water concentration inside the cell to a lower water concentration outside of the cell into the strong sugar solution through a partially permeable membrane by the process of osmosis. To be fair, I think this question should be worth more than 2 marks. We have used the definition, the key terms, we've made it clear which way the water molecules are moving. We have definitely already got 2 marks, but if we look at the cell placed in distilled water, we could also add that water molecules will move into this cell from the distilled water by osmosis. Question 2. The diagrams show the same cell of a common pond plant. Diagram A shows the cell in a hypotonic solution and diagram B shows the same cell in a hypertonic solution. So we need to figure out what those solutions mean. If we look at the cell on the left, the water molecules have obviously moved in because the inside is quite full of water. So this cell must have been in a high water concentration, and the question refers to this as this cell being in a hypotonic solution. So from that we can deduce that a hypotonic solution means that the solution has a high water concentration in it compared to inside the cell. And if we look at diagram B, we can see that the vacuole has shrunk quite a bit. So that means that water must have been at a higher water concentration inside the cell compared to outside. What is a hypertonic solution? We figured it out from the diagram, so we just write the answer. The solution has a lower water concentration than inside the cell. You will already have your marks, but you may have also got marks with the solution has a higher solid concentration than inside the cell. What word is used to describe plant cells placed in a hypotonic solution? The cell in a hypotonic solution has a lot of water in it, and this exerts a pressure. We say the cell is turgid, which basically means firm. A hypertonic solution, water molecules have left the cell and it has become floppy, which is known as flaccid. You may have written plasmolyzed, which is a word used to describe the cell membrane pulling away from the cell wall. Explain what has happened to plant cell in diagram B. Water molecules have moved from a higher water concentration inside the cell to a lower water concentration outside of the cell through a partially permeable membrane by the process of osmosis. The cell membrane has shrunk away from the cell wall. There are 4 marks going, so we have said higher water concentration to lower. We've given the direction out of the cell, we've mentioned the partially permeable membrane, and we've named the process, which is osmosis. Animal cells will also change when placed in different solutions. Some red blood cells are put in a hypotonic solution Describe what would happen to these red blood cells and explain why this is different from what happened to the plant cell in diagram A. A hypotonic solution, as we've already worked out, this means there's a higher water concentration outside of the cells. So look at the picture that I've added. If the cells have a higher water concentration around them, water is going to move into them by osmosis, and that can cause the cells to burst. And why is that different to diagram A? Well, the cell in diagram A is a plant cell. It has a cell wall, and if water moves into it, it won't burst. Water molecules will move from a higher water concentration outside of the cells to a lower water concentration inside the cells through a partially permeable membrane by osmosis, and this will cause the cells to burst. The plant cell doesn't burst because it has a cell wall. Question 3. Cells, tissues and organs are adapted to take in different substances and get rid of different substances. The table shows the concentration of 4 ions outside cells and inside cells. So we've got sodium ions, potassium, calcium and chloride ions. Use the information from the table above to complete the following sentences. Sodium ions will move into the cells by the process of, look at the table. This is not about water molecules now. We're talking about sodium ions, and they are moving from a higher concentration to a lower sodium ion concentration, and this is diffusion. Potassium ions will move into the cells by the process of, well, these are moving from a low potassium ion concentration to a higher potassium ion concentration. So this is active transport. These potassium ions are moving against their concentration gradient. Some students investigated the effect of the different concentrations of sugar in 4 drinks, A, B, C and D, on the movement of water across a partially permeable membrane. The students made 4 bags from artificially partially permeable membrane, put equal volumes of 5% sugar solution in each bag, weighed each bag containing the sugar solution, placed 1 bag in each of the drinks A, B, C and D. After 20 minutes, removed the bag containing the sugar solution and weighed them again. The diagram shows how they set up the investigation. So we've got our 5% sugar solution in each of those tubes, and the bag in drink A got heavier after 20 minutes. Explain why. If there's 5% sugar solution in the bag and there's 0.1% sugar solution outside, that means the water concentration outside is 99.9%, but inside that 5% sugar solution will be 95% water concentration. So remember, we're looking at the movement of water across that partially permeable membrane. There is a higher water concentration outside of the bag, so water molecules moved into the bag from a high water concentration to a low water concentration by osmosis, and that's why it got heavier. In which drink, A, B, C or D, would you expect the bag to show the smallest change in mass? If the water concentration inside the bag is 95%, as we've already established, then for there to be no change in mass, the outside of the bag needs to be around 95% as well. If we work out the percentage of water concentration in each drink, A, B, C and D, remember, if water concentration is even, both sides of the partially permeable membrane, there will be no osmosis and no change in mass. If we look here, the closest drink to 95% is B. Explain why you think the bag you chose in part B would show the smallest change. The water concentration surrounding the bag is the closest to the 95% water concentration inside the bag. So the water concentration gradient is less steep and less water will enter by osmosis. Question 4. Some substances move through membranes. A student set up an investigation. The student tied a thin membrane across the end of the funnel. So that's going to be partially permeable. They put concentrated sugar solution in the funnel. They put the funnel in a beaker of water. They measured the level of the solution in the funnel every 30 minutes. After 3 hours, the level of the solution in the funnel is different from the level at the start. So we're looking at the graph here. Notice that the question is saying the word different. Whatever you do, don't you write the word different in your answer, because you need to be clear that you understand the graph and that you know that level of the solution has increased. The level of the solution has increased because water moves into the funnel from a higher water concentration outside through the partially permeable membrane by osmosis. The student repeated the investigation using dilute sugar solution instead of concentrated sugar solution. In what way would you expect the results using dilute sugar solution to be different from the results using concentrated sugar solution? Give the reason for your answer. Water will still move in because there is still a higher water concentration outside the funnel, but the water concentration gradient between the inside and the outside of the funnel is less steep. So less water or fewer water molecules will move in, so the level of the solution won't rise as much. The lugworm lives in a U-shaped burrow in the sand on the seashore. The diagram below shows a lugworm in its burrow. Some scientists investigated the effect of different salt concentrations on lugworms. The scientists collected 50 lugworms from the seashore, separated them into 5 groups of 10 lugworms, weighed each group of 10 lugworms, placed each group into a different concentration of salt solution and left them for 8 hours. That raises some ethical issues, but I don't think there's any questions about the ethical issues on this particular exam question. They took each lugworm out of the solution and placed it on blotting paper for 30 seconds. Then they re-weighed each group of 10 lugworms. Why did the scientists use groups of 10 lugworms and not just one lugworm at each concentration? There will be variation in the masses, so you can calculate a mean. Suggest why the scientists placed each lugworm on blotting paper for 30 seconds before they reweighed the groups of lugworms. To remove the solution from the outside of the worm. We don't want the excess solution interfering with what we think is a change in their body mass. How might the method of blotting have caused errors in the results? In the method, it says that each lugworm is placed on blotting paper for 30 seconds, but the volume of solution removed from each worm could vary. Suggest one improvement the scientists could make to their investigation. They could use equal sized worms or make sure that they're the same starting masses. The table below shows the scientists' results. So we've got concentration of salt in arbitrary units, 1 to 5, the mass of the lugworm at the start in grams, the mass after 8 hours, and the change in mass and percentage change in mass. The scientists calculated the percentage change in mass at each salt concentration. Why is the percentage change in mass more useful than just the change in mass in grams? Use the information from the table in your answer. Well, the starting masses of each worm are different, so percentage change in mass will enable more meaningful comparisons. Calculate the percentage change in mass for the 10 lugworms in the salt solution with a concentration of 2 arbitrary units. Look at the table at 2, and percentage change is change in mass divided by the original mass times 100. So change in mass is 7.5 grams divided by the original mass, which is 37.5 grams, times 100. That gives us 20%. On the graph paper, draw a graph to show the scientists' results. Plot the percentage change in mass, label the horizontal axes and draw a line of best fit. So we'll plot the points. The line of best fit needs to be done with a ruler, and it definitely should be a straight line of best fit because that's what the points looks like. And I haven't left myself quite enough space to label the x-axis, so I've squashed it on here, but you could make yours more to the side. What do you think is the concentration of salts in the lugworm's natural environment? Use information from your graph to give the reason for your answer. The line of best fit crosses the x-axis around 2.7. So there's no percentage change in mass at this point. This means worms in 2.7 neither gain mass by water moving in or lose mass by moving out. The concentration inside the lugworm is going to be around 2.7, and its environment it likes to live in is going to be around 2.7 as well. The decrease in mass of the lugworms occurs in concentrations higher than 2.7. They lose mass because the water concentration inside their bodies is higher than the surrounding solution, so water molecules leave the worm by osmosis. There are some more osmosis questions in my exam paper videos if you want to have a look at some more. If you found this useful, please give it a like and subscribe to keep up with new content.